Now, before we move any farther with collections, let's talk about this issue about typed and untyped collections, because you're going to hear about it because it's a big deal. And what we're really dealing with is a difference in versions of the .NET framework, because this is one of those classic examples where the original .NET framework didn't cover its bases as well as it could have, and Microsoft corrected this in later versions. Now, first of all, let's talk about what an untyped collection is. And keep in mind, a type, for what we're talking about here, we're talking about a data type, a particular data type or categorization of data like string, integer, and that sort of thing. Well, prior to the .NET 2.0 release, you could have a collection and put strings and integers and stuff like that all in the same collection. Very easy to put them in there. However, when you started trying to read these things, if you violated, one of these things and you need to do a cast or something, then the errors wouldn't be detected until the application ran, which means it would compile. And so a lot of errors were hidden in the applications, and it created a lot of serious hassles for a lot of programmers and for end users. Now, the typed collections corrected that problem. But the way they corrected it is, in the .NET 2.0 release and later, they use a feature called generics to provide typed collections. And the way you can tell if you're using this is when you create your collection, and I'll show you some code in just a few minutes and demonstrate the difference here. Anytime that you see the collection created by, first of all, mentioning the class that's going to be used, like we're going to create a list collection, and you see the type in these angled brackets, that's telling you that we're using one of these generics and we're creating a typed collection. Okay, and so this collection is only going to accept integers into it. So if we did string there, it would only accept strings, and that's going to keep us out of serious trouble a little bit later on as we go through our program. But what I want to do now is jump out into Visual Studio and show you an example of what this looks like using typed or untyped. Now, what I've done is I've put a couple of pieces of code in here, and you'll notice I have this one down here commented out. So let's just go through a little bit of this code up here. This is an untyped collection, and it's built on the ArrayList class that was used early on before the .NET 2.0 release. And notice in the using section up here, we're using system collections and system collections generic, and the generic is the one that's giving us the new functionality. Okay, but notice what we're doing here. We're creating a collection, an ArrayList type collection called numbers, and we're adding 3 to it. Then we're adding 7, and then right here's the problem. We're adding a string to it. So now we have integers in there and we have strings, because notice it didn't ask us for the type. Now we start trying to put these out and we start trying to pull these integers out and loop through them. When we try to cast these and pull them out as integers, we're going to have a problem right here. But notice the comment line right here, this is going to compile. Okay, it will compile. So if I run this, notice no problem. My program compiled up, it's running, it's ready for me to go. But then when I click the button, notice what happens. It sits there for a minute and it says, oh, wait a minute, dude, you got an invalid cast exception. And because we're casting from a number, blah, blah, blah. And the problem is we have differing data types in the same collection. But it let us put them in there and it didn't warn us about them. And so here's the answer, okay? I'm going to comment this one out, and I will come down here and uncomment the typed version. Now notice with the typed version, we're using list, and we're using the angled brackets, and we're telling it this is a collection based on the list class, and we're going to store integers in this, okay? And then we're instantiating a new instance of it right here. Now we add a 3, we add a 7, and then we add our friend the string here. Okay, now notice what's going to happen here. when I try to run this, immediately the compiler says, wait a minute, dude, you got a problem here. And if I do this right here, it's pointing out there's your problem. If I run it again, I will grab that other error message and again point to that same line. So what's happened here, the compiler now is smart enough to see this with a typed collection. Basically says, look, dude, once you tell me that you're going to put a certain data type in here, that's the only thing I'm going to allow you to put in here, and then we're not going to have these hassles of runtime errors sneaking up on us because our collections have kind of gotten out of whack. Now, I can hear some of you guys out there yelling at the screen, yeah, well, that's called good coding, and that's called tight coding, and that's called taking care of business and making sure that I put the right stuff in the right places. Well, it's kind of the same reason we have guardrails, you know, in the mountains and all other kind of stuff, because I don't care how good you are, there are times that stuff will slip through the cracks, and you don't want that stuff happening out there breaking your program during runtime. It's just better to use typed collections. All right, so there's the difference. You'll hear about those. Now you know what it means. Just watch for that. So the bottom line is if you're going to use collections, you probably want to use these typed versions that are provided by the generics classes.